Our third counting concept is combinations. Compare these situations. A, there are 12 contestants in a science fair. How many ways can first, second, and third place be awarded? B, there are 12 contestants in a science fair. How many ways can 3 finalists be chosen? In situation A, the winners are being put in order. So it is a permutation. In situation B, we are just selecting a subset of the contestants without regard to order. This is called a combination. Definitions of permutation and combination. A permutation, as we saw before, is an ordered arrangement. A combination is just a subset or a group with no order. To do the calculations in the situation A, permutation, would be 12p3. Enter that on your calculator, and we get 1,320. There's a formula for this. We don't usually show the work, but this time I want to show it. The formula to find 12p3 is to take 12 factorial and then divide by 12 minus 3 is 9 factorial. In situation B, it's a combination, so it'll be 12c3, which equals 220. Well, that's less than the permutation, so where did that come from? It came from your calculator, but how did the calculator do it? Since the arrangements of the 3 finalists don't count in a combination, we divide out the number of ways to arrange the 3 finalists. So we start the same way as the permutation, but we also divide by 3 factorial for the 3 finalists that are no longer going to be arranged. But you don't need to show this work for the formula, since we can just enter it on the calculator. All you would need to show for this, say for situation B, would be 12c3 equals 220. Example 1. Baskin-Robbins offers 31 different flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. If you go to Baskin-Robbins every day and order a 3-scoop bowl, how many days could you go without repeating a flavor combination? Now that we have both permutations and combinations, we need to be careful which one is appropriate for each problem. The difference is order. If order does matter, it's a permutation. If not, it's a combination. In example 1, it's just a bowl of ice cream, so the order does not matter. Also, the problem actually uses the word combination, and so we definitely know to use a combination. So this will be entered on your calculator as 31, and you're choosing 3, so it'll be entered as 31C3. On your calculator's NCR button, or menu option, will be close to your NPR button, and it works the same way. So enter 31C3, and you should get 4,495. If you're going every day, that means it would take you 4,495 days before you would ever need to repeat a flavor combination. So if we wanted to know how that would be in years, to convert it to years, you would divide by 365, so 44.95 divided by 365, that comes out to about 12.3, so it would take about over 12 years before you would ever have to repeat a flavor combination. Example 2 says a poker hand consists of 5 cards from a deck. How many poker hands can be formed? This is one of the examples I mentioned in the introduction to the on the 11.1 video. Now we can figure it out. Well, we got to decide permutation or combination, so does the order you are dealt the cards make any difference? No, it doesn't. You can switch them around and it won't matter, so that means this is a combination. And there are 52 cards in a deck, so we would find this by typing in our calculator 52 for the cards in the deck, then C for combination, and 5 for the number of cards. Enter that on your calculator and you should get 2,598,960. I'm sure you've heard about example 3, California's lotto game. Well, now we can calculate how small the chances of winning the lotto really are. Example 3. In California's Super Lotto Plus game, there are 2 sections the player fills in. One section contains the numbers 1 through 47. The player bubbles in 5 of these numbers. The other section contains the numbers 1 to 27. The player bubbles in 1 of these numbers, called the mega number. How many different combinations can be formed on the Super Lotto Plus card? Again, they gave us the word combinations, so we know it's combinations, but how would we know otherwise? Well, order is what matters, or what tells us. This is a combination because it doesn't matter what order you bubble the numbers in. It's the same combination whether you do 20 and 27 or 27 and 20, whatever order, it doesn't make any difference. There are 2 different sections that you need to select numbers in. So I call this a double combo problem. You'll have a combination in the left-hand section and another combination in the right-hand section. On the left, there are 47 numbers, and we're going to bubble in 5 of them. So that would be 47, C for combinations, and 5 for the number we're going to choose. 5 for the number we'll choose. Type that in your calculator, and you should get 1,533,939. On the right, there are 27 numbers, but we only choose 1. So 27, C, 1. And that equals 27. To put those 2 answers together to get a final answer, we go back to the fundamental counting principle, which says we always multiply to find the number of ways to combine things. So if we multiply those 2 answers together, that gives us an answer of 41,416,353. So if you buy a lotto ticket, your chances of winning are 1 in 41,416,353.